Some of the other things I really like about Go is how modern it is. Someone asked me about closures. Yeah, so I'm coming to yours in a second. But more than that, it has reflection built in. It has serialization built in. It has channels, which are kind of new, but threading is built directly into the language, not on top of the language. And I'll show you some of the things you can do with that that aren't possible in like a C++ type language. It has concepts I never heard of before, like this defer thing that I'll show you guys in a little bit. Packages are very, very modern, and what that means is that it makes testing easier. It makes compiling your code easier. It makes deploying your code easier. And C is a great language. It's just 30, 40 years old now. So what Go did is they said in 2007, they said, hey, what if we took C and then we added in all the modern things we need for solving problems now? And I like it because it makes me more productive as a programmer. And I think it'll do the same for you. So on to that, let's talk a little bit about threading. I'm going to explain this one a little bit. Please ask me questions because this is a different model of threading than I think you're used to seeing, so feel free to ask questions. First off, I skipped the top of the function where you declare the package and all that. That's there. I'm just only showing part of it, okay? So we have our main function, and what I'm doing is I'm making a channel of bool. Now, a channel is like it's a way for threads to communicate between each other. You can almost think of it like a string tying, like the strings with the phones, and people talk through them, one and the other. So that's how you can communicate through different threads. They can have different types. So I could have a channel of int or struct, string, whatever I want. Right now I'm just using a bool. I don't actually use the type, but and I'm calling this done. Whenever you see go, that's starting off another thread. So if you have a func like this, it's going to create a closure where it captures the done variable. And then what's going to happen is after 5 seconds, it's going to say it's done. And let me run it first, and then I'll kind of show you what it's doing. It's going to tick for about 5 seconds, and then it's going to say it's done. So what's happening is in the main thread, we're starting a new timer that ticks every second. When you have a for like this, it's like saying while true in C or C++, it's just going to infinitely loop. And then we have the select. Has anyone done networking? No? Okay, a little bit. Well, there's select and networking. It works the same thing. And what it's doing is it's saying across different channels, whichever one responds to me first, do that behavior. So I have a channel here, done. And I have another channel, the tick channel. So this one's firing every 1 second, and this one's going to fire, we don't really know, but in the other thread it says 5 seconds. So what's happening is every loop this goes through, and it's just going to block and wait till it gets an input from any of these threads, these channels. When it does get an input, it fires the code. Does that all make sense?
So if I'm reading what's happening up there on the code, right, done is being declared and equal to make. What is make?
Okay, sorry. Yeah, make is kind of like new in a way.
Okay.
So think of it like new.
Okay, and then go is calling a function, and go I assume is create a thread using this function?
Yep.
Okay, what are the parentheses at the end of the curly brace?
Here?
Yeah.
That's actually calling the function. So here you're declaring a function literal,
Okay.
but you could store that off in a variable or something. It's just an object or data, kind of like a lambda in C++.
All right.
Here you're actually running that function, and then that's what is going to happen on the other thread.
Okay, so you're calling go on the running of that function.
And then that's going to happen in another thread now. So execution is going to continue down here.
What is the left-facing arrow on time and moving in?
Oh, thanks. So, very good questions. When you have a channel, you can communicate on them by passing data into them or taking data out of them. So the arrow will say what's happening. So here it's saying that I'm taking data out of time. In this case, I'm passing data into time, or into done. So done is a channel of bool, so I'm going to pass in a Boolean value, true, into it. And that's going to come out the other end over here. Same thing for here. I'm passing in a time duration, and it's just going to wait until that time hits. It's going to fire, and then I just ignore the output. No, it's saying it's basically just passing the data.
Okay.
Yeah.
If you reverse true and done in the direction of the arrow, would it function in the same way?
No. I don't know if this one is editable. So, like this?
No, reverse the arrow. So the arrow points the other way too.
Oh. No, that's not.
Right.
Yeah, that's not even in the language. So the arrow is always going to point in the same way. It's just what direction in the channel. And it's going to specify either I'm passing something into the channel or I'm taking something out of the channel. Okay. Are there any more questions on that? Oh, yeah. Here? Because this creates a channel, and then it's just waiting to get the value from the channel. So time after creates a channel that fires after 5 seconds. Let's do this. Sorry. This doesn't auto format for me, so my code's going to be ugly. That's basically what's happening. It's making a channel time duration, and then it's passing. It's going to wait in the background 5 seconds and then fire on it. It's just wrapped up in a function, so we can't see it, if that makes sense. Yep.
So that's basically blocking.
Mm-hmm. 100%. And that's a lot of the power here. These start acting like semaphores. So threading seems really, really complicated because we have, in C++, we have semaphores, mutexes, critical sections. But really, it just comes down to these two simple constructs here. We want to wait for an input, and we don't care when we get it. Once we're ready for it, we're do something on it. Or we want to send an input. And once it's sent, we're going on about our way. And that's all that's happening here. Yes. Yes.
In the select case down at the bottom, am I able to say what is receiving the information?
Yeah, you could say like, let's see, B. So now it's going to print done true. So you can take that value. So how Go works with threading is the exact opposite of C++. Here you thread by passing that data to whoever's supposed to have it. In C++, you kind of lock and put fences around the data. And you say, hey, no one touch this data while we're working with it. And you lock everyone else away. In Go, what you do is you pass the data to someone else and they operate on it. And then when they're done, they pass it back. That's the default way. You also have the same kind of constructs in C++. But a lot of times this is simpler. It doesn't solve all problems, but it can be used for majority. And I'll show you guys a few more examples. Yeah. Mm-hmm.
Does it treat it like a reference? Like, how does that work? Is it more complicated type?
It depends. So in Go, you have pointers, and then you have value types. So if you made a pointer type, like if this was pointer to bool, then it would pass a pointer. If I just pass bool, it's going to pass a value type. So Go is a lot simpler than C++ when it comes to like reference and value semantics. Okay, I'm going to go on to the next couple slides, and then because I think there'll be some questions on that, but it might clarify some. Oh, yeah. So I'm going to make this smaller. Oh, I don't have a network connection. Okay, I'll do it here. Can you guys see this? Here I have a more complicated example here. I was going to show it on a Go Playground. Is it quick?
It's literally you just hit DP, type in drag, and
Okay. Any capital or just lowercase? Sweet. Sweet. That worked. Thanks, guys. You guys should clap for him because that was awesome. Okay, so I kind of shared this example on the Go playground. And this just gives me a place to run it that's not my computer. Okay. So basically what I'm going to do in this example, this is another example of threading. It's simplified, but it's similar to how a game would work. I'm going to start off 5 or so actors. Let me see. Yeah, these are just comments for the presentation, so it only showed the code underneath. But I'm going to start 5 actors. What I'm going to do is I'm going to start a new thread for them. And then after a certain amount of time goes by, I'm either going to print they update or they finished. Does that make sense? So we're going to start 5 separate autonomous actors that are doing their own thing for a certain amount of time. I set up a random duration for when they update, or when they finish, and when they update. And you see that here. So we say hello when the program starts off. This defers one of the modern features I was telling you about. It works kind of like destructors in C++, and that it happens after the things go out of scope. So you see the last thing that gets printed is goodbye. What's interesting about that now is you can do a lot of your error handling right at the point where you do things. So if you open a file, right below the file you can say defer file close. And it'll take care of closing the file for you. So you can look right away and say, hey, they handled closing this file or they didn't handle closing the file, which is opposite of C++ where they might have done it. You have to go look at the, the code to see if they did it in the destructor or something. Okay, so I'm going to make 5 actors. I have a done channel just like before. And what I'm going to do is I'm going to wait to be done until all the actors have told me they're done. So I have to, the same amount of time, I'm going to listen on that channel 5 different times. And then what happens is for all the actors, I start up, I spawn them off. And then this is actually the behavior they're doing. So what's interesting, though, is some of these guys are updating before I want them to. Because I don't want anyone, like some people are updating before everyone's all reported. I want to be able to stop that. And what's good about Go is that it's very, very easy to add functionality to threads without being too complicated. So I'll show you the next example where I fix that problem. There we go. And I'm going to start off by running it. And now what's happening is all the actors are reporting first, and then they'll start updating after all reported. And how I fix that, I kind of have to look again. Oh, I have a report channel. So I just added one more channel. You see I added a line here, and I added a line here, and then I just listen for the reports. So adding very little bit of code, I changed the behavior now through threading, and I communicated with all the threads, all 5 of the threads. I added 4 lines of code to synchronize them. And that's the power of Go and threading. Are there any questions about that? Because it's probably a lot. Yes. Yeah, good. So I think of them, it's kind of corny, but I think of them as mailboxes. You can put something into it, and then you can't put anything else into it until that's cleared out. So if I'm going to send a package to somebody, I can't receive a package from the postman until he takes it out. Maybe I have a really, really small mailbox, tiny. And so that's how it kind of works, is you chuck something into your mailbox or chuck it into the channel, you wait for someone else to take care of it, and you might say, if you chuck 2 things, you have to wait until the first one comes out first. And it makes thinking about threads really easy, though, because you know that either something's happened on this channel, like here. I know that I can't get into both of these at the same time. Either someone put something here and I'm going to be in here, or someone put something here and I'm going to go down this path. So you never have to worry about cases where both of these things are happening at the same time. So it makes it really, really easy to think about what code is firing. I know that once somewhere between half a second and 1/10 of a second, I'm going to update. And I know that somewhere between 5 and 10 seconds, I'm going to be done. And I know that they're never going to happen at the same time or anything like that. So maybe ask more questions about the channels if there's confusion.
No, I think that makes sense.
Okay, cool. So again, the power here was that I could synchronize across 5 different threads. It didn't actually matter the number of threads by adding 4 lines of code. And all the same kind of constructs to communicate with one thread or with the rest of the program as with all the threads. I can even do this in different ways. So I'll show another example where I do the same thing. Oh. I'm going to run that one. And I'm going to do the same thing now in a different way. And what I do is I make a start channel. I pass it here. And then when I'm ready to, I close. So in the last one, I waited for every single person to report back to me. This time I did the opposite. I told them when I was ready for them to go. Oops. So yeah, what happens here is on the report channel, I'm being more passive about it. They all tell me once they're ready to do stuff for me. But that means I have to keep track of them as the caller. As opposed to on this one, I make a channel. I tell them that they're going to wait till I tell them to go. And then when I'm ready for them, I just tell them to go. Yeah.
So the for loop you have highlighted on the left
Yes.
will be blocked at report channel until there's something for it to take out.
Yep. And that's going to happen. I know that there's 5 actors that I started off, so it's going to happen 5 times. If there was pardon? Oh, cool. Yeah, I like this approach a lot better, but it just shows how easy it is to communicate between 2 different threads in 2 exact opposite ways and very little code. And I've been playing with Go for a while, so it's probably a little more fluent, but these are like the first time you guys hearing these ideas. If it's complicated, it is easy to pick up once you play with it. And that's why I'll go back here. This first example is so fun because this is the exact same as all of those, just with less clutter and less noise. You have the same channels that are pretty much doing the same thing. They're just interacting with less pieces. But it's all the same constructs between them all. I'm just going to run it again because I like it. Yeah?
So in this, if you didn't take out from time dot after, if you didn't have that arrow and you had just the call, would it then block waiting for something to take that out and then just hang there?
I don't know. Nope. Time after channel. I think it threw out the channel, so then it just sent done. So yeah. But if I don't say done now, this is going to go forever. Or if then that's just going to keep running. And I set it to 1 times a second because I did that on accident, and it like locked up a core computer. All right. So that's threading, and it's really interesting because like this select statement is really powerful. You can do things like have a default case that are fire every time something goes through. This is going to print a lot. I don't know if I want to. Oops. And what this is going to do is if nothing else happens here, like so if it's blocking, then it'll just automatically go to default. So this is going to run a lot. Okay. You can also do other things like you can make it so that you start a new timer inside of the select every single time. So every single time through, you can say, I want to wait a max of 5 seconds or something like that to fire off. And you just add a new case that does that. And that's what's really interesting about this language. You can compose a lot of very interesting functionality without a lot of extra clutter or complication. So it's pretty readable. I kind of already told you guys about defer and packages. I'm going to talk about first-class functions in a lot after this. Default inits we talked about compared to C and C++ and range checking. I'll show some examples of reflection uh, in my serialization code for my game engine. I won't show much about networking and text and HTML templates, but Go is built for that kind of stuff, and it's really, really good at it. So my game was networked, and how I had hot code reloading. I don't know if anyone knows what that is, but basically what it is in C++, it's a hard problem because C++ takes a while to compile. So what you do is you shut down your game engine and recompile it so that you can change the behavior and act like you're scripting C++. With Go, that was easy because I just started a web server, and then I used JavaScript to draw everything, and then I would recompile Go. Go is built for the web. And this whole presentation is using networking like locally on my machine, and it's using text and HTML templates to show the slides, show the documentation. So yeah, were there any questions on that stuff?
You said it's built for the web. Is it one of those? Is it kind of a thing where it's going to run really well, like on Chrome, but maybe not on Firefox? Like, how does that work?
No, because it doesn't have any specific browser technologies to it. It's just really easy to write servers and clients in Go. So YouTube uses Go, and a lot of other online services use Go now.
Does the server itself have to have a Go client on the server to run things?
Go client on the server.
Because it's not like it can't just,
No, as long as you can speak TCP. So a lot of times people are passing things around in a binary or a JSON format. So your endpoint, it doesn't matter what language someone else is. Your endpoint just has to understand JSON or something like that. So I wrote, my third year here, I wrote a network game engine. And most of the code was in C++ because it was our networking thing from, does Jeff still teach?
No. Last year was last year.
Okay. But yeah, so, yeah. All right.